All right, guys, welcome back. So we're going to finish up lesson, what are we on? 8.2. So what that says? Yes, 8.2. It's day 2 today. We just have 2 example problems to go through, so it won't take us very long. All right, so on day 1 of lesson 8.2, we looked at how to write arithmetic rules. We looked at an example where you're given the first term and you could easily identify the common difference. Then we looked at an example where you're given the common difference and one of the terms of the sequence, we had to figure out the first term and then write the rule. So today's example, we're going to be given 2 terms of the sequence, okay? So remember, the 2 pieces of information you need in order to write the rule is the common difference, the d value, and the first term of the sequence, okay? So I know that the 7th term is 17 and the 26th term is 93, okay? I need to figure out what is my common difference and I need to figure out the first term. So the first step is to come up with a system of equations that can be used to find the common difference, all right? So when I say come up with a system of equations, all right, if you think about the formula that we've been using, a sub n equals a sub 1 plus n minus 1 times d, right? If you use the first piece of information that's given, that the 7th term is 17, you can fill this in and write 17 is equal to a sub 1 plus 7 minus 1 times d. All right, we could simplify, subtract, and make it 17 equals a sub 1 plus, I was going to write 8 because I'm not subtracting, I was adding, sorry, plus 60. Okay. So that equation has 2 unknowns. So anytime an equation has 2 unknowns, if we can come up with another equation with those same 2 unknowns, we'll have a system of equations, and we know how to solve a system of equations from Algebra 1. So that's what I'm going to do. I'm going to take this other piece of information, do the exact same thing. So I'm going to have a sub n equals a sub 1 plus the quantity n minus 1 times d. Now I know the 26th term is 93. So 93 equals a sub 1 plus 26 minus 1 times d. Subtract. So I have 90. I want it to line up with the other one. I have 93 equals a sub 1 plus 25d. Okay. So again, you have a system of equations, and we can solve system of equations either using substitution or elimination. Now, because they both have a sub 1s, I'm going to use elimination. They both have a sub 1s. They both have a coefficient of 1. It'll be easy to use elimination. So I'm going to set them one on top of the other, make it match up. I wrote that one first. It doesn't make a difference, though. 17 equals a sub 1 plus 6d. And then underneath of it, 93 equals a sub 1 plus 25d. Now, when we use elimination, the goal is to eliminate a variable. So I'm going to subtract everything from the second equation from the first. All right, so 17 minus 93 is going to give you a negative 76. A sub 1 minus a sub 1, they're going to cancel, eliminate, which is the goal. Let me bring down the equal sign, by the way. And then I have 6 minus 25, which is going to give you a negative 19d. Now, this equation has one variable. So I can divide both sides by negative 19. Okay. And a negative 76 divided by a negative 19 is a positive 4. So now I know my common difference is 4. Okay. So I know my 7th term is 17. I know my 26th term is 93. I know my common difference is 4. Again, if the 7th term is 17, you can work backwards and keep subtracting 4 until you get back to the first term. That's going to take longer than what I'm going to show you. All right, so step 2, we know the common difference. The only other thing we need to know in order to write the rule is the first term. Okay, so step 2, find the first term. I'm going to write down the formula again. A sub n equals a sub 1 plus n minus 1 times d. Okay. So if the goal is to find the first term, think about what you could plug in. Okay. You could plug in the common difference for D, and then for n and n sub 1, you could use either one of these two terms that are given. Okay. And what did I do in my notes? I used the first one. Okay. So I'm going to plug in 17. It's equal to a sub 1 plus, well, 17 is the 7th term, so that's what goes in for n, minus 1 times the d value, which I just found out was 4. Okay. So when you subtract and get 6, and then multiply 6 times 4 to get 24, so now we have 17 equals a sub 1 plus 24. And then you're going to subtract 24 from both sides, and that'll leave you with a first term of negative 7. Okay. I'm going to need to erase the board, so before I do, I'm going to write up what I know. I just found that my common difference was 4, and my first term was negative 7. Okay. So my third and final step is to write the rule. Let me erase so I have enough room to do so. All right. So the final step of this problem, step 3, write the rule. A sub n equals a sub 1 plus n minus 1 times d. You plug in your a sub 1 and your d. So a sub n equals negative 7 plus n minus 1 times 4. Distribute the 4 in, combine like terms. A sub n equals negative 7 plus 4n minus 4. Negative 7 and negative 4 are your like terms, which will give you negative 11. So a sub n equals 4n minus 11. And that is the rule that can be used to find any term of this sequence. Okay? That, I believe, oh no, it's not it. That was just example 1. We have one more to do. Getting ahead of myself. All right, so that's example 1. Just one more example for today. All right. So, in order to do example 3, I need to give you a formula. This is for finding sums of finite. Remember, we talked about finite versus infinite. Finite arithmetic series. Remember, when we talk about a series, we're talking about the sum of all of the terms in the sequence. And finite means that it doesn't go on forever, okay? There's a limit. All right, so we use the formula S sub n, S meaning sum, S sub n equals n times the quantity a sub 1 plus a sub n divided by 2. Okay? All right, so we're going to use that in the next example. Example 2 for today. I'm going to ask you to find the summation notation. Lower limit is 1, upper limit is 20, and the rule is 3i plus 7. Okay. All right, in order to use the sum of a finite arithmetic series, let's think about what we need. We need to know the first term, and we need to know the nth term. The nth term in this case is going to be the last term of the series. So we start at 1 and we go up to 20. Okay, so we're going to find, list the steps. Step 1. You're going to find the first and last term. So you're going to find a sub 1 using this rule, 3 times 1 plus 7. Okay, so 3 times 1 is 3, plus 7 is 10. And then you're going to find the last, or the 20th. So a sub 20, again, using the rule that's given, is 3 times 20 plus 7. So 3 times 20 is 60, plus 7 is 67. Okay. Then what you do is you plug into the formula. So I'm trying to find the sum of the first 20 terms, so S sub 20, and that's going to equal 20 times, in parentheses, the first term, which is 10, plus the last term, which is 67, divided by 2. Okay. From there, it's just following order of operation. 10 plus 7, you're going to simplify inside parentheses first. 10 plus 67 is 77. 77 divided by 2 times 20 is going to give you that the sum of the first 20 terms is equal to 770. Okay. And that is it for the rest of lesson 8.3. Okay, I'll see you guys later. Bye.